Hey guys and gals, welcome to the show tonight. It's episode 48, believe it or not. Hopefully the sound is working good, and I believe I cut the theme music off, so when we change screens it will not come back on. We'll see how that works out. See, Ryan's on tonight. Glad to see you on, Ryan. So we're going to do some more wiring, electrical type things. I'm going to try to keep this one basic. So if you're going to wire your car, not doing fuel injection or anything like that, no ECUs or anything, this would really be good to pertain to you. And then I guess we'll elevate the conversation and get into some EFI and stuff like that. I see Bill's in. Hey Bill, how you doing? And we'll see how this works out. I'm in the middle of doing Dave's Chevelle, and I have the front wiring harness made, and I have the main car harness 90% done. And making, filming it, making videos. I want to put a video out on how to do it, but you guys on here can get the inside scoop. I see Kenny's in, Turbo Jixer. Hey man, Chem Bus Decoding, let's go. I think you're a little ahead of us on that deal. We'll have to get you to give us that talk. Yeah, that's a whole nother ball game. But I do want to kind of delve into some of that, not tonight, but and maybe the next week. Definitely want to try to help out some of the garage guys that are just doing their hot rod. And we'll, like I said earlier, we'll work into all the other stuff. So like I said, I got the Mike's in. Hey Mike, how you doing? So we got a bunch of that wiring done on his car. If you need to visit me, Kenny. I know you come down here every now and then. You gotta miss that Florida weather, right? Washington's a little different. But yeah, so that's moving along good, and I'm getting, I think, some good data. Good video and content for the next video. I don't know if you guys saw, I dropped another NMCA Pro Street video. This week was from Atlanta, towards the end of the season. I've got one from Columbus, but unfortunately I don't have the logo, and I've been trying to see if I can, on the internet, I've been trying to search to see if I can find the logo to put it all together. And for you guys that have watched it, I don't know if you guys are enjoying the old school video. Unfortunately, it wasn't a very big production. The videos I actually bought from a guy that used to come around to all the races. So on the videos, he's got Nostalgic Pro Street, Super Street, and Pro Street. So I started out with the Pro Street, but I think I'm going to revisit each one and bring out each of the other classes. The other classes were much larger car counts, so there's a little bit more video to go there. I wish there was a better tie-in to the PA system, but it is what it is. I mean, we're talking quite a while ago. Those were filmed. So anyhow, just going to keep pushing them out. Got the engine block back from TEC for the NASCAR. It's all honed and decked. And Kenny, those were good classes. Especially the Nostalgia Pro Street, which ended up morphing into Outlaw 632, which they've kind of ruined it now. But that was a really good class for heavy back half cars that were didn't want to go bracket racing, but they didn't really have a place to go race. They weren't super competitive because they were in the 28 to 3,200 pound area, and that class was just great. And yeah, it was good times back then. But yeah, so we got that block back, and the bore came out good. Did a clean deck on it, so that thing's gonna be ready to go back together. Maybe I'll try to get some of that done on Sunday. Then I can drop that video. And I did finally find a good 8.1 block for Scott's race car hauler, and I dropped that off to J&J, and I got the phone call today that they said everything looks good. They're going to go ahead and check the main bores anyway, but the bearings look perfect that were in it, and so we're going to go ahead and move forward with that project. I did not hear from Reactor. Now that I'm thinking about that, going over what happened this week, I did not hear from Reactor Flywheel on the flywheel for Scott's Skylark, so I will have to give them a call in the morning. And 4200 update, we had to send the turbo back to ATP. They tried to do some technical diagnostics over the phone, letting us do some stuff. For you guys that maybe didn't know or anything, we're still having, even with the new compressor side turbo, we were still having problems making boost. And I smoked the exhaust and the intake side and found no leaks. When we talked to them, they wanted us to pressurize it, which is nearly impossible because the intake valves are open on some of the cylinders, so that didn't work. But I don't think that was an issue at all. And then while the car has been sitting for 2 months, Leo found that the turbo shaft doesn't want to turn anymore. He could put a socket on it, and with a small ratchet he could get it to spin, but it won't spin by hand. And it's supposed to be a ceramic bearing turbo. So box that up, and that's going back to Cali and see what we can come up with that. There's something going on there. You know, they said we could use our old turbine housing, but I have a feeling that maybe that's not the case, because I never have seen back pressure on this turbo, and I've checked my sensor, and it does work. So we'll see. But those are kind of all the things that have been in the works going on. Motors coming back for Smurf, so we gotta get that back together. We're supposed to be going to Steele, Alabama, I believe on the 20th or the 21st. So we gotta get that back together, get the car tested, and pretty much all the same, but still gotta get it back together and get it tested. It hasn't ran all winter, so get the cobwebs shook out of the driver and out of the car, and make some laps and see if we can go to Steele, Alabama, and take all the money home. So we'll see how that all works out. So that's kind of everything that's going on. So I guess we'll go ahead and start diving into the electrical portion of the show. So what I wanted to talk about, I'm going to show you slides on. I'm just going to kind of go all over the place and see if you guys come up with any questions on what I'm showing, and then we can kind of go from there. I think some of this, Kenny, Mike, and actually Bill and definitely Ryan. I mean, you guys will probably already know a lot of this, but for the guys that are going on, I don't know if my buddy Rick up in PA is on tonight, but he's definitely getting ready to wire his 55, so he's been really looking forward to this. So that's kind of what we're doing. I've heard from some other guys. I know Chris has been working on his Nova, and I had to make some drawings for the relays and stuff to get it so he could understand it and get his car wired up. So which his car is actually running. He sent me a video the other night, and it is running. So he's going to be getting it tuned, and hopefully we'll see that thing on the streets here real soon and back on the racetrack. So good job to Chris for taking the car out of a guy's shop that wasn't getting it done, and took it home and figured it out and got it done himself. And I told him, I said, when you get this all done, you're going to be really happy about that. Oh, Rick is on. Hey, man, it's on your wife's account. That's all right. I don't think Donna will care. But yeah, so that's kind of what we're doing, and so I guess we'll get into it. Um, so on this is a wiring chart I found on the internet. There's a bunch of different ones out there, but I thought this was the easiest to understand. And it just basically talks about how long of wire, positive and ground, your lead is going to a component and the amperage that component's going to use, and tells you what gauge wire you need to run at a minimum. You can always oversize it, but you don't want to undersize it. So when you're wiring up your car, you can find these charts on the internet. There's some that are a little, they're way cautious, and I don't count on this. This was a pretty accurate one here. Just remember when you're running your battery grounds and power to your starter, and you've got a high compression V8, and it's you're looking for 300, 400 amps to crank the engine. That when you have the battery in the trunk, you've got a long lead of harness, and you can see that in that situation they're calling for 1/aught and 2/aught, 3/aught wire. There's a reason for that. If you want the car to spin over good and everything, that's what you need to do. So those are good things for that, just so you can, before you go out and buy wire, you can say, okay, well, this is what I got to wire up. I got to wire up a big cooling fan that's probably going to take 60 amps. And so then you can figure out how much lead from your battery to the relay to the fan, and then fan to ground. Figure out the length of wire and go to a chart like this, and it'll tell you what gauge wire you should run. And this will allow you to not have any issues when you do that. So that's excuse me. That's that. So for most of your GM cars, like on Rick's 55, your painless and most of the other wiring harness kits are going to be the Series 56, which let me pull that down here. So these are the old school. They've used them since the 50s, all the way up into the, with the Series 56, probably all the way up into the 70s, maybe early 80s. So they've been using it all along. There's your male connector with the opening it pushes through and locks in, female. And you can see here that they have current capacity is 20 amps. So think about that when you're wiring up your components. Remember last week I said the first thing you want to do is get all your instruction sheets from all the components you're going to install, and lay out your the color wires you need and where they're going to be placed in the car. But also take notice of the amperage, and then that way you know if the connectors you're using are going to be able to hold it. Now this 20 amp current capacity, that's continuous. So you can have something spike, that's going to be okay. But if you use one of these connectors and your fan is drawing 40 or 50 amps continuous, the connector is going to melt eventually. So just bear that in mind. There's other connectors out there that have higher amperage. On the bottom of this page, they got some of your older school weather pack connectors. These are stuff that we used in the 80s, all like your Electromotive and early Holotech, definitely Excel, Fast, even big stuff, they all use these connectors. Again, these are 20 amp. And that's why a lot of people with nitrous systems melt these connectors, because they try to use these connectors for the nitrous solenoids, and they're drawing more amperage than 20, and the harnesses will melt, and then you'll get a bad connection, and then you might go to use your nitrous and it might not work. So again, just kind of think about what components you want to use with the pieces that you're installing in the car, so you don't want to over amperage the circuit. Let's see here. So if you're going to use a high amperage, and if you look at any of the SPAL fans or any of the other Delta or any other high-end cooling fans, you'll see that they use WeatherPack 480, and that GM made these. These are, I think they're 45 amp continuous connectors, and obviously they make them for, you can make this a fuse holder also, and that, for up to 40 amp working. So again, just check the parts, and try to use the right stuff on there. Deutsch is another connector out there that you can use, and they give you kind of they got the DT Mini series, which is good for under 10 amps. Then you got the DT series, which is most things, a lot of your MSD and stuff like that come with, and it's good for 13 amps. And then they got the DTP, which is a higher amperage, and they're good for 25 amp, and also go up to 10 gauge wire. And the DTM and DT series, they come up in the cavities all up to 12, and they're real nice because they have connectors that have flanges, so you can mount the connector and the panel, have the connector go through a panel. They work out real nice. So again, this isn't going to be on a normal wiring schematic, a normal wiring job, but if you're going to do like an MSD race system or something like that, a lot of the motorsports companies use these Deutsch connectors. So I just wanted to throw that in there. That's the same thing. There's another view of the Series 56. Now, your headlights are going to be Series 59, but it's still the same connector, just a bigger amperage and a bigger contact point. So on these type fittings, there's two crimps. You got a crimp that goes over the bare end of the wire, and then this second fingers that crimp, that actually goes over the insulation of the wire. That makes the connector strong, so you can tug on it and pull on it, and it's not going to come out of the connecting the terminal. So that's why they're there, and I'll show you that in a little bit. And there's just some more. Those are WeatherPack or Delphi 150 series, and they're 20 amp connector, 25 amp connectors also. So those were the connectors. Now I want to go into wiring harness. Let's talk about harness coverings. So back in the day, everybody used to use the convolute tubing, which, I mean, if it gets near any heat, it melts. It's not the prettiest looming situation there is. So I like using this F6 from TechFlex. A lot of companies use this. Holley, EFI, all comes with this on it. You can buy it through Holley. You can buy it pretty much everywhere. But this is it's not very, because it's black, it's not a very good picture, but it actually wraps 180 degrees around your wiring. So you can open it up, put your wiring in it, and close it back up. One of the reasons I like it on a street car, because you can still add wires, take wires out if you need to put a splice in or something. It's very easy to work with. You can use a Terra tape or black electrical tape for the connections, and it makes a pretty nice job if you work with it and make a pretty nice wrap there. Let's see, go the other way. They make these tools where you. This isn't a good angle, but let me see. I think the next picture is. Yeah, so you can lay your wires in this, and then you twist the white piece, and then you pull the handle and push the loom on. It opens the loom and lets it close back up. And you can see right here, right there, you can see how it overlays each other. So that's how it closes in, and just makes a really nice looking harness, I think. Of course, I mean, the high-end motorsport harnesses are all heat shrinked and all that, but I think that's beyond what we want to discuss right now. We want to talk about your hot rod, your drag car, your autocross car, track attack, whatever, kind of lower level racing that we're doing, or street cruising. This is a harness that you can make the car look real nice and clean, and it's easy to work with. It's UV protecting and all that, so it's a good product. There's a different size tools. Unfortunately, I wish they made one for the 1/8. The smallest loom they make that goes over like one 14 gauge or like two 18 or 20 gauge wires. That one you have to do by hand, and sometimes I may say some adult words when I'm doing that, but it's still well worth it, and it comes out real nice when you're all done. I don't think I got a completed picture of it, but we'll talk about that more later on. Let's see here. So let's go into tools. Oh, this is connections. So all right, we'll stay with the connectors for right now. Let me go back one. I wanted to where is? Thought I had one. Oh, it's probably in the crimping stuff. So I didn't get these arranged completely yet, so I apologize. But we're just conversing anyway. So this is the stuff I keep in stock. Actually, this isn't all of my stuff. This is just the larger kits. I also have some travel bags that have some miscellaneous stuff in them. If I'm doing a tuning job or something, I want to be able to get on it. So these are open-end terminals. If you're going to get into a lot of wiring, I would say look into this stuff. For doing your own one car, it may not be as critical, but just to let you know that this stuff is out there. Just like you see on your insulated terminals, the really cheap ones you get from the parts store. How do you keep the ends of the F6 from fraying? That's where I wrap electrical tape. What I actually do, and I should have showed it on this, is I wrap the electrical tape around the wires, one wrap, and then I slide the F6 over it, and then continue the tape over the F6 about 2 wraps. And what that does is now it's tied to the end. It won't even slide back and forth, and it keeps it solid. It doesn't really fray. If you cut it with scissors, or if you cut it with a hot knife, it actually melts the ends and it doesn't go anywhere. I just use scissors because when I'm working in the car, I'm not crazy about having hot items laying on, you might hit the carpet or something and, ruin a piece of carpet, and that'd be terrible. So I just use scissors and then tape them. But like I said, I wrap the tape around the wires first, and then as I peel the tape out, slide the loom over. Now you want to wrap it in the way that the loom is going to lay over it, and then wrap it around the loom. And what that does is it pulls the loom tight to the wire, and it keeps it from sliding back and forth, keeps it right up against the terminal so you don't see the wire insulation, and looks real nice when it's done. So anyway, I wanted to let you guys know these fittings, this type connectors are available. Like I said, the colors are a universal wiring color. So blue is like 14 gauge, yellow is 10 gauge, red is like 16 gauge, and then white is 20 gauge. So these are really great for when you got to add or have a joint where you have one wire continuous. You have to cut it and put a splice and add a second or third wire, because you can find the terminal, say like it's a 16 gauge wire, and you have to add another 16 gauge wire into it. So like you want to make a 3-way ground or something like that. You can use these red-blue connectors, and the connector stays tight to the wire, so you don't have to use a big connector like these straight through and make a mess. So it really works out really nice. Makes it for really clean, a clean connection. As you see, all these connectors are all brazed. They don't have a seam. And like we talked about last week, where these little crimp detents are, that's showing you where you want your anvil, your point on your crimper to crimp the wire, because that's on the opposite side of the soldered joint, because you can't see it because it's soldered. You don't see it. So that's the proper way of crimping it. And again, that's why I don't like the insulated terminals, because you cannot see the joint where it's supposed to be, and you a lot of times don't crimp them right. This is just another bin. This is another. These connectors here are something else. It's how GM has to do the old plastic. Yeah, that's right, Mike. Same way. These are also really nice if you want to make a nice clean splice where you have 3 to 4 wires going into a common joint. These sleeves do that, and you can push all of them into the same component, and it ends up being smaller than the actual wiring section that you're hooking to. So it works out real nice, clean when you have to have a lot of splice. I use these when I'm doing a lot of computer sensors, because you got to have a 5-volt ref and a ground ref, wire going out. And on sensors, the 5-volt and the ground can feed as many sensors as you want. So a lot of times one 5-volt out of the ECU may feed 8 sensors. So this works really well for making those branches and not making it really clumpy in the wiring harness. And these brass ones down here, I didn't get a picture of another box I have. These are the same kind of thing, but they're an open barrel where you crimp them and then they fold in like a spark plug wire crimp. But on a lot of this stuff here, you can see there are seams on that. They're lesser quality connectors, so those you have to make sure you're in the right position when you crimp them down. And these are the double crimp, like the Series 56 and Series 59 connectors, and pretty most of your ECU connectors. These are actually relay connectors. So that's 2 trays I have. Heat shrink, I try to only use glue heat shrink that has a liner inside. It's got a glue liner, so when you heat the shrink and it shrinks, the inner liner melts and fills the cavity, so that no moisture can get in. I mean, you can put the wire under water; nothing's going to get in. It makes it impervious. It makes it a real pain if you have to get back in, because you have to cut it with a razor knife and kind of peel it apart. But it works really good. And if you are going out to buy heat shrink, try to find the heat shrink with glue. You can go to a ton of different companies. I get a lot of stuff from Terminal Supply, Waytech, T&E. There's a bunch of companies on the internet that are American companies that sell good quality product, and that's where I get that stuff from. So here's my my assortment of Series 56. So you got singles and doubles, male, female, 5-ways, and then all the different terminals for all that. Again, you don't have to get into a kit like this if you're buying a wiring harness kit for your car. That usually come with all the connectors you need plus some. So, but I'm just kind of showing you what the different stuff is. Where's my cursor? Here it is. There's 59. See, these are much bigger connectors. And then that's the 480s, and to make fuse holders out of them. I keep a lot of that to make different fuse holders, because that makes a weather tight connection there. So, and then we get computer stuff. Some people will use WeatherPack for wiring connectors, like, and for different things, maybe to hook a radio up or something like that. So, especially if it's under the car or under the hood where it will get wet, these are good. Any type of sealed connectors are really good to use, because that keeps the moisture out. And this is a 280 series. It's just a little bit stronger. That stuff's a little bit bigger. Another box of 280 connectors. I think these are good for 35 amps, I think. And then there's my assortment of Deutsch. And if you do use Deutsch down the road, you want to use the barrel. That's the one thing fantastic about Deutsch, is they have a barrel connector, and to the side there's a crimper, but it actually crimps it by 4 points, and makes a really good connection. You don't have to worry about not getting the crimp right. And then there's the female sides of those. See, it's a nice flange you can put through your panel, and then have the female side to plug into. So that's just some of the stuff I keep in stock. Of course, I do a lot more wiring than most people do. So I just kind of wanted to show you that. But kind of gives you some identification of the different type of wires out there. So I guess the next thing we should talk about is crimps. So again, here's our non-insulated. I'm going to jump this around a little bit. Here's our non-insulated connectors. And like I said, you can see your seams, so you know where you want to crimp them at. It gives you a good idea of, you know, how to get a good crimp out of it. You can see it. You can test the crimp when you're done. If you go to, here's some butt splice terminals I found on the internet, and there's the main problem I don't like about that. See that where this blue butt splice was crimped, they crimped it right next to the seam, so that never made a good connection on the wire. That wire is not encased, so it's going to fail. Moisture is going to get into it. The terminals are going to corrode. Only maybe half the strands are making contact, so it's not going to take the amperage it's supposed to handle. So those are the things why I don't like that, because you can't see what the crimp is doing. I'd much rather do a non-insulated and heat shrink. Takes a couple seconds longer, but makes way better. And I think it looks way better. I think when I see those type connectors, I immediately think the person doesn't really know what they're doing, because if they did, they wouldn't use them because they're not getting a proper crimp. So this is a page I showed last week, and here they're talking about getting the connectors in right so that you can make a good connection. Now on all your Series 56, Series 59, and all of your weather pack type fittings, they're all going to be these double crimp, where you have the smaller section that grabs the conductor in the wire, and then you got the larger one that grabs the insulation of the wire, and that's just to make it have more tug strength. So and you see in this picture how it's when it's crimped, it's full. That's how you want it to be. You don't want any gaps in your crimp. So what I didn't have a lot of crimps I could cut apart, but here's a battery cable. It was a used one that I made a while back. I cut the heat shrink off, and the glue left the green residue there. But you can see when I cut it, let me move in on that. You can see the wires, but they're almost like fuse welded together from the crimp. When you put a proper crimp together and you get the proper load, it practically welds the terminal to all the conductors. This is why a crimp is as good, or in my eyes better, than heat shrink. Because in heat shrink, you got to be careful whether it's a cold joint or a hot joint, whether you're overheating it and the solder runs up inside under the insulation. It melts the insulation. It takes somebody with a lot of practice and good equipment to do proper heat shrink or solder joints. Whereas with crimping, if you have the proper crimper, it does it every time. It's a no-brainer. You're good to go. There's the other end of the same connector. You see that there's no voids. It's all the wires are in there. Now Chris is in. Hey Chris. But yeah, you can see with a proper crimp how that makes it very solid. Now that is on a 1 gauge battery cable. So let's go to here's a number 6 wire, or actually it was a number 10 wire, and you can see there once again it filled the connector and no empty voids, so there's nowhere for moisture or anything to get inside there because there's nowhere for it to go, and it's all formed together to make a good connection. That connection will last forever. So unless it's overworked, but proper connection, proper size connector, proper size wire, it'll last forever. So let me see where we're at here. I kind of didn't have these in order. All right, so here's our a proper crimp on a Series 56, and you can see how that's folded in, and all the conductor is inside the terminal. Be very careful when you're stripping your wires. You don't want a lot of conductor sticking through this end of the terminal. I like to try to keep it flush, or maybe just out just a tick. But you don't want it getting down in here, because then when you push your connector together, it's going to hit the conductors, and it's going to create friction to get the connector fully seated properly. And before I do this connection is when I do my pull test. I want to make sure that that first crimp on the conductor wire is tight. And if that passes the pull test, then I crimp the second part, which grabs the insulation, and what that does is gives it a good working fixture for down the road. When you're working on the car and you got to pull stuff back apart, you're going to pull the engine out of the car, or you're going to pull a switch apart, your light switch, or whatever turn signal switch, whatever you're pulling apart. You don't want the wires to come out of the terminal, so that's why they make these crimps that way. And here's the same ones, just showing how in the smaller section, that's where your terminals are going to go. And see, this one's just a little out front. That's good. All is like that. That's not bad, but you don't want to get into the to the female male side of it. But so you crimp that properly, give it a pull test, then you do your insulation crimp at the end. So these two outside ones aren't done yet, and the center one is a completed connection. So that's how those connectors work. So let's go and look at some tools now. Anybody, is there any questions on what I did so far? Oh, I wanted to show you, here's a bad crimp. I didn't show you this one. And it's on insulated crimps. So here again is why I'm not a fan of these crimps. These crimps were actually made on the seam. Problem number one. Problem number two, the wire wasn't fully, didn't fill the terminal properly. So this one was a lot better, but there's all kinds of voids, and if you cut this apart like I cut the other ones apart, all these little conductor wires would fall out, because it's not a fused joint. Now, a little trick: if you're gonna put, if you have a wire size that's in between your connectors, what you can do is strip them a little extra long, fold it over, and then so it goes into the fitting double. That is proper. As long as your conductor wires are filling the crimp fitting, the open barrel fitting, before you crimp it. Once you crimp it, you're going to get full contact, and it's going to do that full welding type thing that I showed earlier, and it will make a good joint. There's nothing wrong with that. The other thing you can do sometimes is you can take, say you're out of eyelets or something, you can take, say you got a 14 gauge wire, you need a 3/8 eyelet for a 3/8 stud, and you don't have one but a 10. Sometimes you can take a 14 open conductor, cut it right here behind the crimp, slide that in your 10, and put your wire in and crimp it that way. That also is a good joint. As long as the open barrel is full when you crimp it, you'll get a proper connection. So just a little tidbit. Now, obviously, if you're going to put two 14s, you'll have to use a 10. If you have to have two leads coming out, you have to go to a bigger size. But that's when you just want to double check to make sure that that your lead is tight in the open barrel before you crimp the barrel. Glad I saw that. I wanted to show you that. So let's go over some tools. So here's some of the tools I have. Again, I'm kind of a tool hound, so I like buying tools. So I've got tons of tools. So this is an arrangement of OEM This is for TE super seals for like a Holley ECU connector, and then these 4 are all factory Delphi, Packard, Ativa, whichever company the name they're using at this point. But those are all factory tools to make their proper crimps. These are all ratcheting, except for the one for the 480. These are all ratcheting style. Ratcheting is very nice because as you click it down, it's putting a lot more force on, and the plier is made to put only the proper amount of force in. When it's fully crimped and it releases, you know you've made a good connection. You don't have to test it because it's already been preset from the factory. And this is what I like using for my normal open barrel. And there's your anvil, and then it's the half moon there. So that's where your splice is going to go. Your seam is going to go on the top, and the anvil is going to go in and puncture, or not puncture, but collapse, crimp the open barrel, and that's how it's going to make a tight connection. And it's nice it's got a little snipper on the end, so that works out really well. So that's a really good pair of pliers. I didn't get a side top view of it. It's a fairly wide pair. It'll actually grab an open barrel. It'll grab the entire open barrel. I think those are Matco, but Klein. There's a number of people make these. Now you can buy one at your local parts store, but it's like only an 1/8 inch thick. And what will happen with those real thin pliers is the crimp. When you're making it a crimp, the barrel will want to cock or twist, and you'll end up with a not finished crimp. So try to buy a good pair of pliers if you're going to use for open barrel, for eyelets and butt joints and butt connectors and male females and stuff like that. This is a godsend tool for doing adding things into cars that are already together. It's made by Thexton. The part number's on there. It's upside down, 436. But what this is it is a hollow tube, hollow handle with a 45 knife edge on it. So you can go up to your firewall grommet where there's nowhere to put a wire through. You want to run a tack signal out to the engine bay. You want to put a set of fog lights on or something. You got one little wire. You don't want to drill it and have the wire sitting in a drilled hole because it's going to chafe. So with this, you can find a large OEM grommet and you push it through and then send your wire through and then pull the tool back out, and now the rubber grommet will collapse around the wire and you got a nice tight joint. It works awesome. It is so handy for doing stuff. And there's the open end. This one's a little beat up. I need to file it again, but I just file an edge on it and it pushes right through. Pretty much no matter how thick the rubber boot that you're pushing through, but very, very good for doing additions onto a pre-existing vehicle. So I just wanted to show you guys that. So here's my strippers. Remember we were talking about the kind that grab the wire with like upper and lower jaw, and it rips the insulation off. This actually cuts the insulation and peels it off. And you can see on there that they're opposite sides, like it says 8 and 10, it says 12, 10, 12, 14. So what I always do is I start with the larger one, pull it and see if it'll pull the insulation. If it doesn't, then I move to the next one down. What you don't want to do, anytime you're stripping wires, you don't want to cut into the conductor wires and lose 3 or 4, 8 or whatever conductors because you used the wrong size opening to strip the wire. All you want to do is cut the insulation and peel it off. You don't want to touch the conductors. That's why I'd rather use this style, or insist on using this style. And this is my one for small wire, 22 to 16 gauge. That's what they look like on the outside. And just to give you guys a heads up, where was that other one? Oh, it's not there. I know where it's at. There it is. This is the style I want you to stay away from. This one just has a top flat and a bottom flat, and then in the orange section is the part that grabs the insulation, and when you close down on it, it just takes a bite and then pulls back. And a lot of times it will take the conductor wires with it. It's a fancy way of using your teeth or using a set of side cutters. It's not the right way to crimp or to pull the insulation off your wire. Don't do it. You're going to run into problems doing it. I know all the tool guys sell them, and I've argued with them before. It's not the right way. In fact, I took wire and showed them why it wasn't the right way, and they're like buyer beware. So I'm just showing you guys, don't use them. This is the proper way to use it. You got a jaw here that grabs the insulation. You've got the proper cutter for the size wire you're using, and it cuts it right off. So that's what you want to use. Buy a good set of these. This Klein here will go all the way down to 16. So for general wiring, that one will do all of your wiring that you need to do. And then your battery cables, you can use a razor knife or something like that just to cut the outside rubber, the insulation off. But scissors. You need to have a good sharp pair of scissors in your toolbox. So I already mentioned I cut my F6 loom with scissors, and you can cut convolute tubing with scissors. It makes a way nicer cut than trying to use a set of side cutters or something. The other thing that you want to use scissors for is cutting your electrical tape. Try not to. And if you've probably seen this in the past, and some people even tell me, oh, don't use electrical tape because it unravels. It unravels because you didn't cut it. You stretched it till it snapped. So what that does, it's plastic or rubber or vinyl basically. So what happens is when you snap it and pull it to hi honey when you pull it like that to cut it apart, you stretch it. Now when you wrap it around your wire and you're done, you're moving on to your next project, that stretched section is slowly trying to go back to its original shape, and so it comes undone, and you're never going to make it stay on. Plus the other fact is the glue has all been stretched out of proportion, so it doesn't have a good edge. If you take your time, wrap your wire, and you can stretch your wire a little bit, your tape, I'm sorry, stretch your tape a little bit while you're wrapping it around your wiring or your covering, your wire shield, F6, convolute, whatever you're using. Then leave about 1 inch, let it normalize, cut it with the scissors, and then wrap it around your component. That will stay good. The glue is solid. You didn't touch the glue, so it's not going to have oils from your fingers on it. It's going to glue itself to the rest of the harness, and it won't come apart. Maybe if you soaked it in oil, it may come apart, but for the most part, it'll last for years without ever coming apart. It'll look nice and clean. Buy a good sharp pair of scissors. So these are just some universal pliers I have. These are what you want to use for making your connections, not the open barrel, but the Series 56, Series 59, and all your ECU style components. There's specific jaws for each type of fitting. So if you're not sure, you're using something new, take a couple fittings and make some test crimps so you can get a handle on what size you need and which one's the right jaw to use. Here's a Matco one. It's got the color codes on it and stuff. It's a ratcheting style again, so when you pull it all the way tight, it makes a solid connection. This is the kit that, if you guys need to go buy a wiring kit, this is one I've ran into, and I think it is pretty good. It pretty much covers everything you need. So you've got your blue tool down here for pulling weather pack connectors apart. Your round spades, it'll take those apart on the old school weather. You've got these 3 pairs of pliers that are for your Deutsch style connector. You can see the little jaws in there, and again, these are ratchets, so when you pull them all the way tight and they release, you know you've made a full crimp, as long as you use the proper. They have the size of wire and size of crimper that you connector that you use on those, the terminal. So, but these two crimping pliers here, this blue pair will do a lot of series 150 weather pack Delphi, and the red pair will do, you can do open barrel Deutsch. It works really good for a system, series 56, 59, or any other type of male female terminal like that, where you have the one for the first grab for your conductors and your second one for your insulation, for like making relays and harnesses and stuff like that. Really good pair, and it's got releases for a lot of the other terminals. It's one little kit. Here is the part number. I don't think this was $100, so it's a really good kit, and it'll do, I would say probably it'll do 80% of the wiring you're going to do. And then you have the anvil type that I showed earlier for doing your open barrel terminals, and you pretty much got everything you need. A good set of crimpers or strippers and a pair of scissors, and you can go to work. Here's another set. This is, I should throw these away. This is Matco, and this is the crimp that they give you for the insulated terminals, the yellow, blue, and red terminals. This is what you're supposed to use. It makes the messiest looking crimp, and this is, a major tool company's answer to how to fix it. I don't ever use this. It just, when I grabbed all the pliers out of my drawer, I pulled this one too. You can see it's got a lot of rust on it. I don't use it very much. Here's another pair. This is a Snap-on. It's another one I bought because I thought, oh, look, it's going to be real nice. It's got this short head on the top of it, so it'll be great for working under dashes and stuff. You got your strippers right here. It's not that good of a tool. You have to be really careful with the stripper part, because if you don't pull at a 90 degree, it will strip the conductors right out of the connector when you get a twist in it. And then because it's such a short handle, you can't get enough load to properly put a crimp on the open barrel. So all around, another tool I probably should just throw away. I don't ever use it. It just sits in the toolbox, and it does not get a good crimp. When I would use this, I'd have to use both hands and squeeze as tight as I could, and even then, when I did my test on the terminal, they'd fall apart. So when you are looking for your anvil style crimper, go to the one like I showed in the first view. I didn't put a tape measure across it, but that pair are like 10 inches long. You can get a good amount of leverage on that to get a good crimp. This one, not so much. And this is the last tool that I believe is a must-have in your toolbox. This is what you would call a flush cut. So when you close these cutters, it's completely flush on this edge. The cutting edge is on the other side, and it goes down to this edge. I don't know if I got another picture of it. Yes. So see, when you're done, it's completely flat on this side. So whenever you're pulling zip ties, this is the tool you use. You use that flat side against the head of the zip tie. You'll never have a cut arm by rubbing against the zip ties. Please, everybody, I hate working on cars that they used a regular set of side cutters and didn't cut the ends, the tails off of the zip ties. They will slice you open like a razor blade. I'm sure you guys have all ran into this before. These pliers will not do that. Snap-on makes them. This is a pair I bought from Home Depot because I do all my wire cutting with this pair of pliers because it makes a flat cut. When you use a regular pair of dikes or side cutters, the cutting edge is beveled on both sides. So when you cut the wire, you've crimped the edge of the wire. Bill says he's guilty. Yeah, these two, I think this comes with a miniature pair of needle nose, and I think they were $8. And let me tell you, your arms will thank you for using this tool. That is one of my biggest pet peeves, working on a car that somebody else has worked on. And they got zip ties everywhere, because let's face it, we build our race cars and our street cars with zip ties. There's nothing wrong with that. They're great harness holders and good for all kinds of stuff. They're great clamps for vacuum hoses. You can use zip ties for anything. But when you don't get that flush cut on the tail, you've got a razor blade sitting there just watching, waiting for your skin to get close to it to slice you open like I don't know, fillet you like a fish. So that's something you should definitely invest in, and go out to your car and go clean all the cable ties that aren't cut properly already there. Get them cleaned up now. I'm just telling you, you'll love it. Mike says GM zip ties are all razor blades. Yes, they are. But with this kind of tool, you can do it. Yeah, Bill says I buy them by 1,000. I do too. I buy 1,000 item bags. Now, one thing I forgot to get the slide on here. There is a tool you can buy. They're not very much money. I've got one from Uline, but you can buy fancy ones that are all aluminum and everything. But there are cable tie pliers, and you actually pull the tail, and it stretches the tail out, slices it, and when the tail relaxes, it's a flush cut. That's also a good tool to use, but this is really easy to use while you're making your loom. Snip, 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 done. And the cable tie pullers, it's a pretty big gun, and it's kind of cumbersome sometimes to get in, and sometimes, especially if you're got a harness and it's cable tied. I like to cable tie my harness about every 4 inches, and it's already mounted in the car. Sometimes you can't get the gun into an angle to where you can get a good flush cut. These will get anywhere. They're tiny little guys. They'll go everywhere. And then these are the tools I showed earlier for the F6. You can use it for convolute tubing. Any kind of tubing that needs to be opened to get wiring in. These things work great. These are from Tech Flex, the company that makes F6. And again, I wish they made a couple more sizes, but this is what they do make. And there's just a good clean picture of the Klein strippers that I like using. You can see how they got the cutters made specifically for peeling the insulation and not cutting the conductors. All right, so that was the main gist of everything. One more thing I wanted to go over, and this will kind of lead into maybe next week. If you guys see anything. Now, I use this for the thumbnail for the video, and I don't expect you guys to all figure this out, but this is just your common electrical symbols. If you're looking at a wiring schematic, especially OEM schematics, they'll use these switches and push buttons and stuff like that. You'll see conductors will be they'll have a dot where they're connected. If there's nothing, if it just bumps up, it's not connected. Some of the stuff, capacitors stuff, we wouldn't get into that. Ground symbol, that's a common symbol for whenever you're making your when you're writing a schematic. Fuse, that's always what they show. Diodes, we'll get into these later on. It's a one-way, basically it's a one-way flow valve or check valve for your wiring. It lets electricity go one way, but it won't let it go the other way. Very handy for having for all kinds of things. If you've ever installed an MSD 6AL, 6A, 7AL, and there's always that little bag of connectors and terminals, you always see there's a little diode, and what a diode is just a little two thin wires, a little black cylindrical section with a silver stripe on it. That is a diode, and the silver stripe is showing the stop. The arrow is the side that's black going up to the line. So why they put that in that kit is if you have an older GM car or any car that was originally a points car, and you put the MSD box on there, when you shut the car off, the MSD backfeeds the ignition and will keep the car running. You put a diode in there, and then that stops it because now the backfeed can't reach the ignition switch, so the car will go dead. So that's kind of what a diode does. But anyway, I just want to show you that. We can go over some of this stuff more in depth next week. I did not show that, Mike. You're right. I totally missed that. I have multiple tools for. Mike asked if I showed the crimper for the battery cable. So I'll show that next week. I've got a large pair. It looks like bolt cutters that is a crimper. I've got a hydraulic crimper from Harbor Freight, which I modified to do a better job. And then I still have one of the old anvils that you put on your vise, and you put your terminal in there, and then you smashed it with a hammer, and that crimped did the crimp. So it's basically doing an anvil just like the open barrel plier style. It's a larger tool for a larger cable. I will show them next week. I didn't get those pictures. I apologize about that. But let's talk about relays for a second. And we'll wrap up after this. So here's what people sometimes aren't fully grasping what a relay is. So in wiring, we talked about this already. Your connectors, we didn't mention switches, but switches all have a amperage rating. So you can't put your 40 amp fan on a toggle switch in the car with the toggle switch only being rated at 10 amps. It'll fry the connector as soon as you turn it. So that's what you use a relay or a continuous duty solenoid. They're all basically the same thing. And in your relay or solenoid, you're going to have a coil. And that coil, when it gets electric and ground applied to it, becomes a magnet, and it sucks the lever and makes this points setup make contact. And this side is where all your heavy amperage is going. So your coil is only going to take about 1 or 2 amps to energize. And then on the normally open, normally closed electrical connectors, that's where you put your high amperage connectors. And it has points contacts in here that actually are made for the higher load. So that's how that works. The coil closes it, and that either opens the normally closed and closes the normally open, or vice versa if it's a double, if it's a 5-prong contact. So that's basically how it works. Mike says, I have the Harbor Freight one, but don't like how it crimps. Yes. Yeah, it's tedious. You have to really work around the connector and crimp it like 18 times to get all the flat spots done. So what I did was I took one, cut a V in one side, let's say the female side, and then I took the my welder, and I built up the other side and ground it into an anvil shape, and that goes into the V and crimps awesome. I'll show that next week. So now you have to come back. Just kidding. So here's your normal schematic for a relay. This is actually only a normal open relay. So 30 is always coming from your power source, your battery. Or if it's going to be a ground switch, it would come from ground. 87 is always going to go to what you're going to activate. Cooling fan, fuel pump, starter solenoid, whatever you're going to activate. And then 85 is typically your ground. I know, Chris, I apologize. When we were talking about the relay, I couldn't remember which way it went. But 85 is typically your ground side, and 86 is your switched power side. And look at this. There's a diode there. And the reason they put the diode there is that's to stop flashback from the coil when the relay is de-energized. Now, it's not important for a common circuit with a toggle switch, but if you're going to use this relay and it's going to be triggered by an ECU, the ECU cannot handle the voltage flyback to the circuit. It's not made to handle that. So this diode, or sometimes they're a resistor, that stops that from happening. So if you're using a relay on an electronic item, always look for one with either a diode or a resistor to stop the flashback on the relay. Holly does make a for their trans brake solenoid, they make a trans brake solenoid safety wire, and that all it is a diode. So you can buy that or just buy the relay with the diode built in. You don't need to buy that. So here's how you would normally use a relay. 85 is ground, your 30 is going to your battery, and you see there we get the swivel line. That means it's fused. On this circuit, it's fused at 25 amps. We have our plastic El Cheapo lit toggle switch that if you put anything more than 2 amps through it, melts on your dash. So this is why we use a relay, because we want to run these two lights that are 10 amps apiece, fans that are little baby fans that draw 10 amps, 2 fuel pumps, whatever you want to run. It's going to require more amperage than what your toggle switch is going to handle. So those circuits go to our 87, and then 86 comes from our toggle switch. So we have a 3 amp fuse going to power up the toggle switch. We have ground on the opposite side so that the light eliminates when you turn it on. And then you've got the load, which is sending voltage to the relay, closes the contactor, and turns your high amperage component on. That's what a relay does. It's an electronic switch, if you will. If you think of it that way, it's kind of easy to figure out. It takes a low amperage circuit to turn it on, and it can handle the work of the high amperage circuit. Now, sometimes you want to have a circuit that shuts off. So this is perfect for a trans brake solenoid. You want your trans brake solenoid to work every time you hit the button, right? But what you don't do, you have nitrous on your car, and what you don't want is when your foot goes to the floor and your trans brake is on, you don't want the nitrous to turn on. So what you do is you use this 5-way terminal with a normal open and normal closed. So what you would do is 30 would go to your battery, 87A, which is your normally closed circuit. So when the rest of the relay is dead, that circuit is got continuity. That would go to your nitrous solenoid. Okay, 85 would go to ground. 86 would be a signal wire from your trans brake to send power here. So what would happen is when your trans brake is off, there's no power going to 86, your nitrous would be connected by a natural occurrence because it's a closed circuit. When the trans brake is activated and you send 12 volts here, that's going to polarize this magnet, and it's going to pull the switch to 87, which is to nothing, and so now your nitrous cannot come on while your trans brake is on. As soon as you let go of the trans brake, the solenoid, the magnet loses its strength to pull the switch. Switch closes, nitrous turns on. But you could do this with anything that you want that would normally be on, and you want it to shut off momentarily. This is how you would do it. Again, that's why relays are very handy. You can do all kinds of things with them. This is another Bosch one connection. They're all the same. Oh, that was the slide we already looked at. Here's another one. And again, the same thing. This one's actually drawn properly. See, the signal is spring loaded to the 87A. When this magnet energizes, it sucks it away from the 87A and goes to the 87. And then when it de-energizes, it pops back to your 87A. And this one again includes a diode for signal feedback. So that's how a relay works. Your big starter solenoids and all that, it's just a larger version of the same thing. So whenever you're laying out your wiring harnesses and laying out your wiring system like we talked about last week, and you're putting everything on paper, keep an eye on what voltage is some of those components are going to have to, the amperage that they're going to draw, and realize that you may need to put a relay in the system. Again, like we were talking about last night, depending on what components you have in your hot rod, or your daily, or your truck, or your camper, whatever you're wiring, we're integrating multiple components. Your painless or auto wired works, or there's a bunch of companies out there that make wiring kits. They're not going to they'll send a signal wire and a memory wire to your radio, but they don't know what needs to be connected to your radio. They don't know you have an amplifier. They don't know all these things. So it's your job, first thing you do before you do any wiring on the car, you get your instructions and start laying out notes on what components are going to be connected and what outside things you're going to need, whether you need a relay or inline fuse, or how many amps a switch or the connectors you're going to use are going to be. Figure that all out, and then set it up in a spreadsheet before you start wiring the car. That way you don't have to remember all these nuances while you're wiring the car. You're going to be knee deep in all the wiring and trying to figure out where it all goes. So again, that's why, like I showed last week, and we'll wrap it back up again next week. But you make that spreadsheet, whether you hand write it or use computer, whatever you want to do, but just make it legible, or in boxes or some sort, or maybe one page for each portion of the car. Just make sure you keep them all together so you don't lose a page. But that way, while you're actually putting wire in the car, you can look at that section and know, oh, I forgot, I got to add a wire for this component, or that component, whatever you're doing. You're putting, cooling fans on the engine that aren't, a lot of the wiring harnesses are only going to give you a trigger wire for your fans. They're not going to give you the relay and the heavy wire from the battery and all those things for your fans. You're going to have to add all those things in. They're only giving you the basic system, and it's up to you to integrate all your other components that manufacturer did not sell you into it. Now, if you're buying everything from one person, then hopefully they've already done that due diligence for you. But that usually doesn't happen. Like in Dave's car, I've got 20 different systems I'm adding into this car. Remote control for the door locks and the windows, multiple switches for the power windows, exhaust cutouts. It's all getting integrated to a custom switch that's mounted on the dash. We're putting USB ports in the side of the console for phones and any other late model. We all use USB for everything nowadays. So you need to do all that. You need to figure it out. Hey, John, glad to see you made it in tonight. So that's the big thing. You just have to realize that when you do a complete car wire job, it's not going to be a 10-hour job. It's probably going to be a 20 to 30-hour job, depending on how many extra components you put into a car. A job like Dave's is going to be about a 40-hour job. But between the installation book from Painless, and then all of my notes, and then all of the instructions from all the different vendors, all put into a big Ziploc bag, 5 years from now we can pull that stuff out and we'll know exactly where the wires are going and what they're doing and why they're doing it, because we have a schematic. We have of the Painless harness, we have our spreadsheet of all the component wires that we had to add in to connect all the other devices and where they were added in at. So, I mean, it doesn't tell you, 2 inches from here, that's where the connector is, but you know that it's under the dash center, it's under the dash right hand, left hand, under the hood, under the carpet, in the trunk. So, there's at least you're starting with something. That's what the biggest thing is. 5 5-10 years from now, when you have to add something to the car, or a component, one of the components you installed fails, and you try to do some diagnostic, or you call the manufacturer and they want you to do diagnostics, with all that paperwork, you'll be able to figure out exactly what you did and be able to be able to perform whatever diagnostic test they want you to perform, and you'll sound like a smart guy because you knew exactly what they were talking about because you've got it on paper, rather than going, I don't know where that wire is, I don't know, and especially for the people that wire their cars all with one color wire. Well, I mean, when you have to go back in and do anything, you're going to pull your hair out. So it's always smart to start off with a wiring kit that is made by a manufacturer that has labeled wiring, and obviously they'll usually have multiple colors in there, hopefully wires with stripes. And one of my pet peeves is when you're adding wire to a system is to use the same color wire. That's, to me, is very important because it keeps all of your information still making sense. Now, with like the painless, I doubt you're going to add any wire. So far, all the harnesses that I've done on Dave's car, I've had to cut 3 to 4, 5 feet out of each loom. They give you plenty of wire, and a Chevelle is not a small car, so it's not like I'm doing a small car and that's why I got so much wire. I would say that even if you were doing a full-size truck, you're going to have extra wire. So it's nice of them to add that, because what I do with all that extra wire is I roll it up, put zip ties on, bundle it, put it in a box, and then the next job I do, hey, I've got some white interior courtesy light ground wire. I've got some orange courtesy power wire. I've got light blue, dark blue front turn signal wire, and it still has the labels on it and everything, so I can just add on if I needed to add on or whatever I'm doing. So those are the kind of things, when you get into doing multiple jobs, you can start accumulating a nice extra stuff. So, all right, well, hopefully that was informative. Kenny says they have wiring templates for Excel. I'll have to look into that. I made my own, but that would be really handy, if there's something good like that. And so when I get the main harness done on Dave's car, I still have the Holley Terminator harness to do too, because once again, on his car I'm hiding all the wiring, and again, being that the Terminator kits are made for universal installation, there is tons of extra wire. So I'll be doing the same thing I did with the main harness. I will make my spreadsheet with all the connectors, where they're going to be placed, where the coolant temp is, where the TPS, IAC, all that stuff, crank and cam sensor, oil pressure, fuel pressure, wideband, and then I will use my rubber hose method and get my lengths, and then I will disassemble the harness on the bench and modify the harness to fit the car the way I need it to fit to do that. Now, I'm doing that because of the job I'm doing on that. You don't have to do that if you don't want to. You can just pull the harnesses up and make a small bundle under the dash. That's fine if you don't want to get into ripping all those harnesses apart. But that's what I do. That's how I do my harnesses, and that's why I've got all the connectors and all the tools and stuff that I have, because I have to be able to do anything that they've done. So, all right. So next week I will show the crimping tools used for the batteries. I'll show all the ones I have. I'll have some crimps on there. Bill says, now I don't have to wonder what thing about my wiring job. Now I know. Yeah, and Bill, you did an awesome job for the guy doing his car at home. You blew up the Holley schematics into a big sheet, and were able to make notes and tag your wires and everything. That's very smart. Try to keep everything to where you can understand where you're wanting. I know I've had you move uh, uh, wires like we just did the trans temp, and it was very easy. I pulled out a J1 B12 and put it in J2 A3 or whatever it was. I don't remember, but because you had all those notes, it took you 5 seconds to make that correction. So a lot of preparedness before you do the job goes a long way to making the job go smoother, make more sense, and you won't get lost in the wiring spaghetti. Because when you first lay the harness in the car, you're gonna go, oh my goodness. So, but I will show. I gotta pull the harness out of Dave's car one more time and finish up some of the looming. So I will pull that out and I'll get pictures of that so you guys can see how I branch everything off. And again, I used my vacuum hose and kind of went down the system and figured out where the main trunk of the wiring would go, and then brought branches off of that. So it all kind of makes sense. And when I'm all done, you'll look underneath the dash and there'll be minimal wiring in a car that's got a ton. So makes it nice and clean, organized. You don't have to worry about harnesses laying all over stuff and chafing and doing all those things. So with that, I guess we'll pull a plug on tonight. I appreciate everybody coming in. I hope it was informative. If you guys have questions or you come up with questions during the week, you're thinking about stuff, put it in the comments. I always check that stuff multiple times a day. So, and then with that, I'll give me some insight to maybe go over something some more next week. So with that, I hope you guys have a great rest of your week. And, see y'all next Tuesday. See ya.